Assalamu alaikum. Can you see the slide? Hello.
Assalamu alaikum, sir. Sir, yes, sir.
Why so less participation? Already 5 minutes gone. Okay, we start with the lecture 5 of cement. Okay. We'll start with manufacturing of cement. Okay. So you know that what are the constituent components of cements like silica, lime, alumina, iron, of the magnesia, okay, gypsum, alkalis. These are the constituent components. But the main raw material is limestone, as we have seen in one of the slides, that limestone comprises almost 60%, and to some extent, in some of the literature, in practical field, it may compose 80% also. And there are other raw materials like silica, alumina, or clay, iron oxide, and other materials. So what happens? At first, the raw materials are crushed, then that's screened, then that is stored somewhere. That is called stockpiling. And then these raw materials, okay, after crushing, now they're mixed with definite proportions, okay, to obtain the raw mix. And then they are mixed either dry mixing or by wet mixing. There is huge difference between dry mixing and wet mixing. That means if the mixing is done by water, so in that case, water will be there. Then at later stages, you'll be seeing that this raw mix need to be actually heated. So that means more amount of water, more amount of heat will be required. That means more amount of fuel will be exhausted, which is not environment friendly. So there are debate and controversies whether the mixing should be done by dry mixing or wet mixing. Okay, once mixing is done, either by dry mixing or wet mixing, okay, then the prepared raw mix, it is fed into a rotary kiln. And the material which when it passes through the kiln, so the temperature is gradually raised, and it raised up to 1300 to 1600 degrees centigrade. The process of heating, okay, that means raising the temperature, okay, is known as burning. And the output is known as clinker, which is 0.15 to 5 centimeter in diameter. 5 centimeter means almost 2 inches in diameter. So that is the normal procedures, production steps of cement. And then the clinker is cooled and stored. After that, with that clinker, actually, that clinker is mixed with gypsum. Gypsum at the ratio of 3 to 6% to adjust its setting time. We know that gypsum is added to retard or to slow down the setting time, okay, of clinker. And after that, packing and marketing is done. So we just came to know how that clinker is produced. Okay. In the next slide, actually, you see the industrial setup. The industry, how does it happen? If we have any scope, we'll try to take you to a cement factory. Maybe we're targeting Holcim and Lafarge cement factory, which is just okay. If you go from Dhaka on either side of the Mega Bridge, we have a plan to take you there. Inshallah, we have to take you to a cement factory, whole level 2. So this is the arrangement. Okay, that means actually, the boulders at first are placed into the container, and then through vibration, and then through an impactor, okay, and then they follow through a process, and in the process, actually, the rocks are segregated and stored in some silos, and then at later stages, you add other materials which are required to produce cement, and then blending takes place. Okay, and then after blending, and then whether the materials are mixed in proportionality or not, so that is seen through X-ray analysis. Okay, that is very important for quality control. And after that, then okay, when they are fed into the silos, okay, and then afterward the temperature is also given, and then temperature gradually increased, and at the one stage clinker is formed, and then when the clinker is, once you get the clinker, then you add gypsum to retard the setting out process. Okay, gypsum is added, and as finished product at one stage you get the cement, the fine cement. Okay, so in general that is a procedure followed in the industry. Now, if you see that in terms of chemical reactions and temperature, what happens? So you see from this side, on left side, the raw material support, and from this side heat is being applied. What happens? The first step, what happens is this is called the dehydration zone. So at this dehydration zone, the free water, it goes out, and then with the increase of temperature, then clay decomposes. Clay means that the alumina, so that decomposes, and afterward limestone, okay, which is the major part of the cement, that also decomposes, and gradually the initial compounds, okay, the compound of cement is formed, okay, and then step by step the dicalcium silicate and then tricalcium silicate. So these are the compounds are getting formed, and after that, that means the clinker is being formed, and then the temperature is gradually lowered down. Okay, so then you get the clinker, and then from clinker again after crushing, then you get the fine. You add gypsum and other things. So this shows that the mechanism, okay, how water, free water is evaporated, then how the other components decomposes gradually, how other compounds of clinker are formed gradually, okay, at various temperatures. So clinkers look like this, okay, and gypsum looks like this, which is added after the production of clinker. Okay. Now, if you see temperature-wise, it is not exactly that the temperature is given. Just to give you some idea, normally temperature varies from type to type cement. The temperature varies. In generally, what happens that reactions in the kiln. What reactions take place in the kiln? Okay, at 100 degrees centigrade, the free water that remains with the raw materials, it evaporates, and between 150 to 350 degrees centigrade, that the clay components, it has got some loosely bound water, so that is also lost by the time the temperature reaches 350 degrees centigrade. And between 350 to 650 degrees centigrade, the clay decomposes, and then okay, and then silica oxide, alumina oxide, this part, the decomposition takes place. And then at 600 degrees centigrade, the magnesium carbonate, okay, they actually decomposes, okay, and at 900 degrees centigrade, the calcium carbonate decomposes, okay, decomposition takes place, and between 1250 and 1200 degrees centigrade, that cement is being formed at liquid state, okay, and various compounds of cement. What are the compounds of cement? Those will be named later. We'll be knowing. Bock compounds, okay. What is Bock compound? We'll be knowing later, okay, just after 2 or 3 slides. So that means the clinker is being formed, okay. You can say that clinkering process begins, and between 1400 to 1500 degrees centigrade, the clinkering process actually completes. And then after that, gradually the temperature decreased, and when the temperature comes down to 100 degrees centigrade, the clinker leaves the kiln and falls into cooler, so where you get the cement. There are certain issues, okay, related to this production, and some we're talking about some materials and also some other issues. One issue is gypsum. So we know that gypsum is added, okay, with the clinker. Now, if too much gypsum is included, so it leads to disruptive expansion of the hardened paste or concrete. That means when you produce, when you get the cement, and when you make the cement paste, or with the cement, when the cement is mixed with concrete. So what happens if you add too much of gypsum, afterwards, it will cause the expansions, okay? And in terms of alkalis, the alkalis in the form of alkaline hydroxide, so they react with the silica of the aggregate, because the silica of the aggregate is reactive in nature. So alkalis, they react with the reactive silica, and they cause the volume expansion, okay, after hardening. Setting and hardening we discussed okay, in earlier class, we also discussing today. So this process may take years, okay? So it instantly doesn't take place. The reaction of alkali, the after effect of alkali, actually you will feel after many years. There is one term that is called insoluble residue. It is the fraction of the cement which is insoluble in hydrochloric acid. Hydrochloric acid, so this is an indicator. This is an indicator to determine that actually how much of actually silica did not take part in reaction in the process of forming compounds, okay, during the burning process in the kiln. Normally, all the compounds, actually this is a test type, okay? So when cement is produced, if you take a sample of cement, then if you put it in hydrochloric acid, okay, all the cement is supposed to be soluble. So if some parts remain insoluble, actually that part is silica. So that means the complete reaction, the completeness of the reaction did not take place. So the amount of insoluble residue determined by chemical analysis later on, it indicates the completeness of the reaction in the kiln. So according to STM CE-150, okay, that is standard, the insoluble residue amount should be less than 0.75%. That means that silica, which did not react in the process of forming cement compounds, should be less than 0.75%. 0.75%. There is another term called loss on ignition. So it is these topics are actually useful, important for you for writing short notes. Okay, so understand carefully. Loss on ignition. So this is also a test, okay, which is carried out on the cement, produced cement. It is the loss in the weight of cement after being heated to 100 degrees centigrade. It indicates that the prehydration, that means, or the carbonation due to prolonged or improper storage of cement and clinker. So you have produced cement, or you have produced clinker. You have produced clinker, which will be later on crushed to produce the cement. Okay, so if the cement or the clinker is stored for a prolonged period, okay, or if the storage is not proper, so at that time prehydration, that means chemical reaction between water and cement, and then carbon dioxide from the air may mix with the cement and clinker, so that may take place, and that's how actually what happens. The volume of the cement increases, okay, and then when you heat by 1000 degrees centigrade, actually weight of the cement again comes down. So if cement is exposed to air, water, or carbon dioxide, so cement is exposed to air. So what happens? Water and carbon dioxide from the air, they're absorbed, and by heating the cement up to 1000 degrees centigrade, so cement loses these two substances. So according to STM CE-150, loss on ignition should be less than 3% for ordinary Portland cement. This is a test, loss on ignition test. So the chemical reactions which takes place, okay, within the kiln, okay, so it is said that the potential reactions actually will remain in an equilibrium position, okay, that means a standard one, but it depends on certain factors like fineness of raw materials. The raw materials like alumina, silica, lime, and magnesium, and other things which we are using. So the fineness of those raw materials and the proportioning and the intermixing. So this is an important factor. And then temperature is also an important factor, because high temperature will cause a chemical rapid chemical reaction, and the time, okay, that means how much time the mix is kept in the critical zone of the kiln. So everything is so actually meticulously controlled, the proportioning, the temperature, then the water, then in which segment, and how much time the material should be there. Everything is actually carefully controlled and monitored, because that is required for the quality control of cement. And also the grade of cooling of clinker, because you know that at one stage the clinker will be cooled. So the rate, that is the rate of cooling. So actually the rate, based on the rate of cooling, actually the internal compound of the cement, okay, that means okay, the internal structure, what is the internal structure? So it will have an effect on that, the rate of cooling of clinker. Setting and hardening of cement. So during burning and fusion in rotary kiln, all the ingredients okay, of the which we came to know in the composition of ordinary cement. So they undergo chemical combination and they form bulk compounds. Okay, know the term bulk compounds in the finely grained cement. Okay, what is bulk compound? We'll see what is bulk compound. So bulk compound is bulk compounds, or we can say compound composition of PC or clinker. So what happens? The oxides, they interact with each other in the kiln to form more complex compounds. Basically, the major compounds of actually the cement are, that means there are some constituent materials, as we discussed, okay? Now, in the process of manufacturing, okay, okay, in the clinker, okay, so these four elements are formed. One is called tricalcium silicate, one is dicalcium silicate, tricalcium aluminate, and tetracalcium aluminoferrite. Very important slide. Okay, okay. So this is the chemical formula, tricalcium silicate. That means okay, 3 parts of calcium oxide and silica oxide, dicalcium, 2 parts of calcium oxide and silica oxide, tricalcium aluminate, 3 parts of calcium oxide and aluminate, and tetracalcium aluminoferrite. That means it has got components of calcium oxide and then Al2O3, aluminum oxide, ferric oxide, and in short, tricalcium silicate is denoted by C3S, dicalcium by C2S, tricalcium aluminate by C3A and C4A. So you should just memorize these terms: C3S, C2S, C3A, C4AF. What is C3S? Tricalcium silicate. C2S, dicalcium silicate. C3A, tricalcium aluminate. C4AF, tetracalcium aluminoferrite. Note one thing, that the percentage in the OPC, okay, when the that means in the cement, the tricalcium silicate it comprises 55%, okay. Then the next one is dicalcium silicate, and then tricalcium aluminate is 12%, and 8% is tetracalcium aluminoferrite. So tricalcium silicate is the majority portion of the compound, okay. And then in terms of heat of hydration, you see, out of the 4 elements, tricalcium aluminate, it produces the maximum amount of heat, that is 865 joule per gram, and then tricalcium silicate, and then dicalcium silicate. So that means if you want to reduce the heat of hydration, what we have to do? We have to increase the proportion of dicalcium silicate. That means you have to add those materials which will produce dicalcium silicate. Okay. Hello. হ্যালো, শোনা যাচ্ছে?
জি স্যার, শুনতে পাচ্ছি স্যার।
Okay. So note this slide very carefully. Percentage and heat of hydration, and the tricalcium aluminate, it produces maximum heat, and in terms of volume, the tricalcium aluminate, it produces maximum heat, and tricalcium silicate, it is 55%, okay, and lowest heat is produced by dicalcium silicate. Now, very important, as I said, that these bulk compounds are very important, because we'll see what are the actually the role of these bulk compounds. So at first we start with tricalcium aluminate, or C3A. What happens after addition of water in cement? So in cement, these 4 compounds are there. Okay, so when you add water to the cement, tricalcium aluminate, or C3A, so out of these 4 compounds, C3A is the first to start hydration. Hydration means the chemical reaction between water and cement. And this C3A is responsible for early setting of the cement. So we learned about setting of cement, hardening of cement. Setting of cement means change of state of cement from the liquid state to a solid paste. So this is called a setting, okay, in short. So actually C3A is responsible for setting of the cement. And during this setting of the cement, okay, which takes an early part, okay, when you add water with cement, actually a huge amount of heat is produced, and that is also due to this C3A. But C3A does not contribute any strength to the concrete. So what is the role of C3A? It is responsible for early setting of the cement. It produces considerable amount of heat, but it does not contribute any strength to the concrete. Okay, that is the role of tricalcium aluminate or C3A. In terms of tricalcium silicate or C3S, so after C3A, okay, then the second man, that is the C3A, that C3S came into action. So hydration of C3S starts, and this C3S, it is responsible for the initial strength of the cement. You see, C3A does not contribute to strength. It is responsible for only setting of the cement. That means change of state. But gaining of strength, initial strength of cement, that comes from C3S. And actually, the strength which cement gains within first 7 days, that happens due to C3S. Okay. Now about dicalcium silicate or C2S. So after C3S, the third entity, that is C2S comes, okay, to play its role. C2S reacts with water. It reacts at a very slow rate, and the strength of the concrete after 7 days is mainly due to hydration of C2S. So ultimate strength of the cement comes from C2S, which comes to the feed at later stage. C2S starts contributing strength after 7 days of its placement, and it continues about 1 year. Okay, and that means it takes almost 1 year. C2S remains effective for gaining strength of the cement. And though the rate of getting strength goes on decreasing with the passage of time. So from 7 days onward, C2S becomes activated, and it contributes to strength, and then it continues up to 1 year. But with the passage of time, this gaining of strength decreases. The fourth element is tetracalcium aluminum ferrite. Actually, this is a byproduct. It is more or less inactive compound, and it does not play any significant role in setting or hardening properties of the cement. Okay, it just remains there as in a small percentage, maybe 8%. So although the process of setting and hardening of cement takes place simultaneously, actually these two processes takes place simultaneously, but there is a difference between these two. But if the question is what the difference between setting and hardening, then you have to write in this way. Setting of the cement is changing plastic state of cement to stiff solid state. That means which is not strong enough and has a very small compressive state. That means during the setting of the cement, actually the change of state takes place. Actually, no strength gaining process takes place. On the other hand, hardening of cement is the rate of gain of strength. Okay, and with the passage of time, as the hydration continues or proceeds, so the compressive strength of the product goes on increasing. So if you see the structure of the hydrated cement, just try to understand that at any stage of hydration means the chemical reaction between cement and water. Okay, the hydrated paste, okay, consists of very poorly crystallized hydrates of various compounds referred collectively as gel. That means cement gels are produced. If you look at this slide on the right, you see actually the figure shows a simplified model of paste structure, cement paste. Okay, here the solid dot represents gel particles, and the interstitial spaces, that means between the gel particles, so they are called the gel pores. The white one is called the gel pores, and a space marked C. These C, these are called capillary pores. So in the cement paste, if we take a macroscopic view, you will find gel particles. Then between the gel particles, there are gel pores. And in addition to that, there are some larger pores that is called the capillary pores. Okay. So gel particles, gel pores, and okay. That's how cement paste look like. Regarding composition of some important cement, so composition varies. Later we'll learn that there are various types of cement. So normally in composition part, we discuss in general that the constituent materials and the bulk compound, the 4 elements. We said that okay, this is the percentage. For example, C3S is 55%. Okay, like that. But it varies. Okay, it varies depending on the type of cement. Okay, so in the book of Good Challenging, table 5.3, just see that. Just see that the book is available in the library. So there we will see that for what type of cement, what should be the composition. And then that is the constituent materials, okay? The basic materials, the raw materials. And then in terms of bulk compounds, okay, Gucci, same book, table 5.4, it says that the variation of bulk compounds, okay, will vary the properties of cement. Just see that, nothing to memorize from there. So what happens during manufacture of cement, if there is free lime left, that means limestone are used, which is said 60% and it may be up to 80% is left in the cement, and due to under burning of clinkers. The clinkers are not burned to the standard temperature, so some of the lime may be left as free lime. Okay, now this free lime, which is uncombined, okay, in the finished cement, later on they will get problems. So they will cause expansion and disruption of cement. Okay, so remember this thing. Now, just one thing that in Bangladesh, what happens, the Holcim and Lafarge, this is cement company, you know that Holcim and Lafarge, initially there are two separate companies and later on they merged together. They have a factory in Chatak, in Sylhet, and actually they carry the raw materials. As raw materials, they carry limestone from Meghalaya of India. In Chatak, on the opposite part is Meghalaya, India. So they have got 17 kilometers actually. What should I say? The conveyor belt. Within that 70 kilometer, 10 kilometer falls within Bangladesh and 7 kilometer falls within India. So through the conveyor belt, limestone, okay, which is a raw material for cement, so that comes to their factory. There actually, then they collect some silica from the silt area or some clay materials, alumina, and then they import gypsum and they mix and they produce clinker there also. So actually the cement, what Holcim Lafarge produces in Bangladesh, so the clinkers, actually majority of the clinkers come from their own factory. And in the factory side also they produce cement, and some of the clinkers, they have got two other factories in the Meghna Bridge and one factory in Khulna. So from this factory in Sylhet, clinkers they send to those other three factories, and if they sometimes fall short of clinkers, they import it from Indonesia. Other than Holcim and Lafarge, almost all the cement producing factories, they actually import clinkers from various countries, and after importing clinker, they add gypsum and other materials, and they grind it, and they produce the cement. Now we'll see. I'll try to show you the Holcim Lafarge, how do they do it, or the types of cement they produce nowadays. I'll show you, okay, in later classes. We'll be discussing about the properties of cement. One is chemical composition, fineness, setting time, strength, soundness, and heat of hydration. Chemical composition. So by this time you know that the major substituents of cement are C3S, C2S, C3S, C4F, and that means out of this four element, C3A is very quick reaction, and then the C3S comes into action. Then C2S, its reaction is slower, and C4F negligible. So if you see at this graph, which shows time on the x-axis and strength on the y-axis, you see C4F in terms of actually strength, it does not have any effect. C3A, actually a negligible amount of strength. Basically, its contribution is for the setting of the cement. Actually, it is a C3AS. Actually, for the initial 7 days, strength comes from C3S. So they take some time, and then the strength keep on increasing. And then C2S, which becomes active after 7 days. So initial 7 days, you see the curve, it is slower, then the strength keep on increasing. So after 7 days onward, up to 1 year, okay. So the strength, whatever cement gains, that happens due to C2S. Fineness of cement, very, 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 very important property of cement. Fineness of cement is a measure of the sizes of the particles of cement. So it is expressed in terms of specific surface of cement. What is a specific surface? A specific surface is the total surface area of a material per unit of mass. So the finer the particle, the more the specific surface will be. And then since hydration, that means chemical reaction between cement and water starts at the surface of the cement particles, so So it is the total surface area of the cement which represents the materials available for hydration. So the finer the material, okay, the finer the cement is ground, the greater will be its specific surface, and then the greater will be its chemical reactions. That means the rate of hydration will be more, okay. But fineness of grinding, okay, it is important because it increases the workability of the concrete mix, okay. And rate of hydration, that means chemical reaction between water and cement, it depends on the fineness of cement particles. And to gain rapid development of strength, higher fineness is necessary. Okay, so we said that if you want to gain rapid strength from cement, then the cement should be very fine. This is one. So it will depend on application. Okay, in where you want to gain rapid development of strength, at that time you will get the cement very fine. But too much fineness is undesirable because it will generate greater heat, and then concrete is likely to develop cracks. Okay, because greater heat means quick chemical reaction. That means quick setting, quick hardening. Then that will cause the crack in the concrete. So, but one advantage of fine cement is that fine cement bleed less than the coarse one. Bleeding means the coming out of the water from the cement paste when water is mixed with cement. So if the cement is too much fine, okay, so then it will bleed less than the one which is not that much fine, which is more coarse. Now, setting time, it refers to a change from liquid state to solid state, and during setting, cement paste acquires some strength, negligible amount of strength, and water content has an important effect on the time of setting. Now, for cement, actually, various companies that produce cement, and those cements are sent to various labs for testing. In our lab also, we receive sample from various companies. So actually, we carry out test. That means the water content. Okay, that means with cement, what happens with cement and sand? We mix water in a certain percentage, and that certain percentage, the specific percentage will cause, okay, a standard whiteness. That is called the normal consistency of cement. That means you have to mix water according to the standard proportion. Now, how to understand that when actually what is that standard amount of water? So that is determined through consistency test. And that means the amount of cement water in the cement paste varies from 20 to 30%. And to measure the consistency of cement, and apparatus will show the later slide that BCAT apparatus is used, okay, to determine the normal consistency. So what is normal consistency? Actually, in BCAT apparatus, you'll be seeing that a plunger is used, okay? Standard, it has got a standard size and shape, and that plunger is allowed, okay, to penetrate in the cement paste, okay, for 30 seconds, and it is allowed to penetrate for 33 to 35 minutes. So at that time, actually, you have certain amount of water. So standard is that the plunger will be allowed to penetrate for 30 seconds, and it will be allowed to penetrate 33 to 35 millimeter. So at the amount of water at which actually this standard is obtained, okay, that is the normal consistency for that type of cement. So that is done through trial and error method by varying the water cement ratio. And during the setting process, actually, a lot of things happens. Temperature change takes place. Then actually, hydration, chemical reaction between cement and water. Okay, and due to which the gel, which I have shown in the previous slide, those are formed. Okay, around each particles of cement. Now we'll be talking about the setting time. Okay, so there is one term called initial set and another called final set. Initial set means the beginning of the noticeable stiffening. Stiffening means gaining of rigidity. That means changing of state from liquid to the semi-solid or semi-solid state. So initial state indicates the beginning of the process, and final set may be regarded as the end of the process or the start of hardening. Okay, that means when the cement loses its plasticity. So if you come to initial set, So this is a stage in the process of hardening. Okay, we said that setting and hardening starts almost simultaneously, and then so this is the stage of the hardening that after this any crack in the concrete will not unite. So after initial set, okay, if there is any crack is developed during initial crack, okay, and after this initial set, if there is any crack, actually you cannot repair that crack. And it also refers to the completion of setting. That means this is the time, actually initial setting time. We said that during the hydration process, huge amount of heat is produced. So that happens during this initial setting time. Okay, peak temperature of the cement paste is reached during this initial setting time. And initial setting time of ordinary cement is not less than 30 minutes. Again, this not less than 30 minutes is variable. It varies from type to type. It depends on types of cement. Then final setting time, the stiffening of the cement paste increases as the volume of the gel increases. We know what is gel by this time. And then the stage at which this is complete, the final hardening process begins. So initial hardening, that means initial setting and final setting together actually marks the initial hardening. And then once the final setting time is completed, then final hardening process begins. Normally, it takes 3 to 10 hours, okay, for final setting. So this is the beaker apparatus. There are other apparatus also, as I said. So there's a plunger, and this is a container where cement paste is placed. Then you allow the plunger to penetrate for 30 seconds, and we allow it to penetrate for 30 to 35 millimeter. And then at that time, the paste that you have got, it has got certain amount of water. So you see that at what water content actually this standard, that is 30 seconds and 35 millimeter is achieved. So you vary the amount of water and the water content at which actually this is achieved, that is called the consistency of that is the consistency test of the cement. So in the laboratory, once you'll be doing the test, you'll be doing more in details. So factors affecting the setting time. So temperature is an important element, okay, because the higher the temperature, the higher the rate of reaction, okay, everything will be changed. As I said in the first class in case of Burj Al Khalifa, the temperature differential is so much, it is daytime and night time. So to avoid casting of beam and column, that means concrete, they used to avoid daytime because daytime temperature is very high. So they used to do the casting at night, or they used to mix ice with the cement so that the temperature is kept under control. So temperature is very important. At the same time, humidity also, because if the environment is too much humid, so from the air, water and carbon dioxide will come and they will take part in the chemical reaction. Amount of water is important, you understand. Chemical composition of cement, that is important. And fineness of cement. By this time, this issue is discussed. Now, we will discuss about 2 special issues, very important for short note, for CT, midterm, or final exam, whatever. Okay, or there may be a different question that what is the difference between flash set and false set, or what do you understand by flash set and false set, or what are the reasons for false set, like this. So these are the flash set and false set. They are the abnormal settings. What causes flash set? What is flash set? Flash set is the immediate stiffening of cement paste in a few minutes after mixing with water. So within few minutes, actually, cement paste will become very stiff. And when this happens, a large amount of heat is produced. Okay, this happens because due to the reaction of C3A with water. You know that C3A produces more or less 860 joule per gram amount. That is the heat that it produces. So during flash set, huge amount. One thing is that the stiffening of cement will take place very quickly within a few minutes, and then huge amount of heat will be produced. Number 2, and then how to prevent that? So gypsum, the job of gypsum is to slow the setting time. So gypsum is placed in cement to prevent this flash set. Okay, and but the rigidity that is developed. So you want to make it normal. Okay, so it cannot be overcome. and plasticity of the cement cannot be regained with the addition of water. That means to make the cement workable, you need to add water. So if we add water, at that time, the cement will become normal, and then it will, from flat set, it will have a normal set. By adding water, you can do that. But in case of false set, the other term is called false set. False set is the rapid development of rigidity, okay, of cement paste without generation of much heat. In case of flat set, huge amount of heat is produced. In case of false set, huge amount of actually no heat is produced. And here the rigidity that is developed, so that cannot be removed by adding water. Here you have to do what? You have to go for further mixing, okay, of the various elements. So in this way, without losing any strength, the cement paste restores its plasticity and it sets in a normal manner. Now, what are the probable causes of false set? We are going into the little bit details of the false set. What causes false set? The probable causes of false set, okay, there are three causes. We'll be going one by one. So one maybe when gypsum is ground by too hot of a clinker. That means when you add gypsum with clinker, when the clinker is too hot, what happens? You know, there can be a combustion of gypsum, calcium sulfate, and two molecule 2H2O. So gypsum may be dehydrated because the clinker is too hot. Then it turns, it becomes hemihydrate. That means calcium sulfate. Earlier it was gypsum had got 2 of H2O. Now it has become half of H2O, or it may be anhydrate. That means it may lose its water. So when this happens, so the materials when react with water, so they hydrate to form needle-shaped crystals of gypsum, okay, and that causes the stiffening of the paste, okay, in case of false set. Another one happens during storage. What happens if the cement is kept in the storage for a long time, or if it is exposed to the environment? That's why actually cement should be stored very carefully under shade, and it should be protected from water and free air and other things. Okay, and then the place where you are placing cement, actually the bed itself. Okay, you have to ground. You have to take care of all those things. Storing of cement is very important. So what happened during storage, and you should not store cement for a longer period. You know, you'll see if you by this time you have noticed that if cement is stored for a long time, the cement becomes very rigid and it becomes almost like a stone. So during storage, what happens? Alkalis in the cement, they make carbonate, and alkali carbonates react with calcium hydroxide. From where you get the calcium hydroxide? The calcium hydroxide is liberated by the hydrolysis of tricalcium silicate, that is C3S. What is hydrolysis? The chemical breakdown of a compound due to reaction of water. So when C3S breaks down due to chemical reaction of water, so at that time calcium hydroxide is liberated, and this calcium hydroxide reacts with calcium alkali carbonates, and they form calcium carbonate, and this calcium carbonate precipitates, and that causes rigidity of the paste. So that is also another cause, alkalis, and then subsequent reactions. They are another cause of false set. So now we know two reasons of false set. The third reason is the false set can take place due to the activation of C3S by aeration. What is aeration? When the air enters into material. So when air mixes with C3S, okay, at moderate high humidity. That's why I said that humidity is very important. When humidity is very high, so from the environment or from the atmosphere, so air will come and it will react with C3S, that is the calcium silicate. So what happens? When the water is environment is very humid, that means there's a lot of water. So that water is adsorbed. Mind the term, not absorbed, adsorbed. There's a fine difference, the difference between absorption and adsorption. In case of absorption, it is the process in which a fluid is dissolved by a liquid or a solid. Okay, but in case of adsorption, it is the process in which atoms, ions, or molecules from a substance adhere to the surface of the absorbent. So একটা হচ্ছে কি তোমার হচ্ছে অ্যাবজর্ব করে ফেললো, একটা হচ্ছে নো, এটা সারফেসের মধ্যে লেগে থাকা, সেটাকে বলা হচ্ছে তোমার absorption. So water is absorbed on the grains of the cement. Okay, and then তার মানে কি সিমেন্ট গ্রেইনের মধ্যে ওয়াটারটা এসে তোমার লাগে। So this তখন কেমিক্যাল রিঅ্যাকশন শুরু হয়ে যায়। this freshly activated surface, that means cement grain যে সারফেসটা আছে সেটা কিন্তু অ্যাক্টিভেটেড হয়ে গেল, ঠিক আছে, due to the water absorption. Okay, so that causes very during mixing, okay, rapid combination with water, okay, that causes rapid hydration, and that may also cause fall set. So for fall set, we know what is fall set, and we know 3 regions of fall set of cement. In terms of compressive strength of cement, okay, we're talking about the strength part of cement, compressive strength of cement. Normally, the compressive strength at the time of failure for OP ordinary cement should not be less than the following value. That means after 3 days, okay, the compressive strength should be in terms if it is PSI, 2300 PSI, and after 7 days, the compressive strength should be 3200 PSI. Okay, that is the compressive strength expected from cement. Cement is actually known for its compressive strength, not for tensile strength. And in terms of tensile strength also, it has got little amount of tensile strength. Means after 1 day curing, 3 day curing, and 7 day curing, what should be the tensile strength of cement that you can see the slide. For example, after 3 days of curing for rapid hardening cement, so tensile strength should be 435. For ordinary cement, it should be 290 PSI. Soundness of cement, very important, very, very important. Soundness of cement is defined as the volume stability of the cement paste. The cement paste actually should not undergo large changes in volume after it has set. Setting হয়ে যাওয়ার পরে এর মধ্যে ভলিউম চেঞ্জ হওয়া উচিত না, বাট ভলিউম চেঞ্জ কখন হয়? The presence of যখন সিমেন্টের মধ্যে ফ্রি লাইম থাকে, দ্যাট মিনস যে লাইম যদি এক্সেস অ্যামাউন্ট ইউজ করা হয় তো কিছু লাইম রিঅ্যাকশন করে না, তারা রিঅ্যাকশন না করেই কিন্তু সিমেন্টের থেকে যায়. So that free lime causes and also magnesia that causes unsoundness. Unsoundness means changes in the volume of the cement paste. That is called unsoundness. Cement is unsound. Cement unsound means cemented volume expansion হচ্ছে, ঠিক আছে, এটাকে বলবো তখন আমরা বলবো সিমেন্ট ইজ সাউন্ড. তোমাদের যে কোশ্চেন আসছে যে সিমেন্ট সাউন্ড, হোয়াট ডু ইউ মিন? সাউন্ড মিন্স দ্য ভলিউম এক্সপ্যানশন হবে না, ঠিক আছে, সাউন্ড সিমেন্ট. So these substances, that means in the process they saturate very slowly, okay, and cause volumetric expansion of the concrete, and that causes disintegration of the concrete. So if cement is not sound, and cement may not be sound due to the free lime and magnesia, that will cause this disintegration of the concrete ultimately due to volumetric expansion. Now the term is heat of hydration. By this time you know that the chemical reaction between water and cement compound is known as hydration. So what happens when cement sets, heat is liberated, and then gradually cement paste get hardened, okay, and the rate of heat evolution as well as total heat depends on the composition of cement. So cement is the constituent material গুলো আছে সেটা কি material তৈরি যেটা ডিপেন্ড করবে heat evolution টা. At the same time, the rate of hydration and the heat evolve এটা সিমেন্টের ফাইনেসের উপর also depend করে, যেটা আমরা already have discussed. So low heat cement, that means if you want a cement who should produce low heat, okay, normally these are used for mass concrete construction. Concrete যখন mass concrete construction যখন হবে তখন কি হবে, তোমার হিট অফ হাইড্রেশনের জন্য হিউজ অ্যামাউন্ট অফ হিট প্রডিউস হবে. তো সেজন্য আমরা কি করব, ইন্টেনশনালি আমরা এমন একটা সিমেন্ট ইউজ করব যেটা লো হিট করবে. তো সেটা কিভাবে করা যায়? In types of cement we learn that, and there are some physical properties of cement which are shown. Just table 5.5, just see that. Okay, now we're talking about the types of cement. There are types of Portland cement. One is normal cement. The normal cement has got medium rate of hardening. It is suitable for majority type of work, and but normal cement can be attacked by acids or sulfates which is present in soil and groundwater. So soil concrete যে পার্টটা which will be in touch with soil or substructure যে পার্টটা which will come across the groundwater. So groundwater এর মধ্যে যদি অ্যাসিড এবং সালফেট থাকে তাহলে কিন্তু অর্গানিক Portland cement will not function effectively. This is very important. Rapid hardening Portland cement. So its manufacturing process is similar to ordinary Portland cement, but chemical composition is different. What is the difference? Lime content increase করা হয়, stiffness increase করা হয়, এবং তোমার যে এটার তোমার ক্লিকারিং টেম্পারেচার, ফাইনেস অফ গ্রাইন্ডিং, সো অল দিস থিংস আর ডিফারেন্ট ফ্রম নর্মাল সিমেন্ট. বাট এটার একটা বৈশিষ্ট্য হচ্ছে যে ইট গেইনস হাই আর্লি স্ট্রেংথ ডিউ টু হাই ডিগ্রি অফ ফাইনেস ইন গ্রাইন্ডিং. তার মানে র্যাপিড হার্ডেনিং Portland সিমেন্ট যেটা থাকে সেটা ফাইনেসটা থাকে হাই, এবং এই জন্য কিন্তু তোমার হাই আর্লি স্ট্রেংথ হয়, স্ট্রেংথ এত হাই যে অর্ডিনারি পোর্টল্যান্ড সিমেন্ট 7 days এবং 28 days এর স্ট্রেংথ গেইন করে, র্যাপিড হার্ডেনিং পোর্টল্যান্ড সিমেন্ট 3 days এবং 7 days এর মধ্যে স্ট্রেংথ গেইন করে। And এটা একটা অ্যাডভান্টেজ আছে কিন্তু, because there are places where we want that cement should gain its strength very rapidly. That means অনেক সময় তোমার ফর্মা মানে কলাম বা বিম, আমরা যেটা বলছিলাম বুর্জাল খলিফাতে যেটা হয়েছিল যে সাপোজ 144th কলাম কাস্টিং হচ্ছে, তো সেখানে যে ফর্মা গুলো আছে, তো সেখানে র্যাপিড হার্ডেনিং পোর্টল্যান্ড সিমেন্ট ইউজ করা হয়েছে। হ্যাঁ, সরি, সেখানে সিমেন্ট আমরা বলেছি SCC, সেলফ কনসলিডেটিং বা সেলফ কম্প্যাক্টিং সিমেন্ট ইউজ করা হয়েছিল। ঠিক আছে, দ্যাট মিনস যেটা তোমার আসলে র্যাপিড হার্ডেনিং হয়, সেটাতে কি হয় যে ফর্মওয়ার্কটা থাকে, তো র্যাপিড হার্ডেনিং এর কারণে কি হয় সিমেন্ট তোমার হার্ডেন হয়ে যাচ্ছে, তো ফর্মওয়ার্কটা উপর দিকে উঠিয়ে নিয়ে যাও, দেন ইউ পোর মোর অ্যামাউন্ট অফ সিমেন্ট আর কংক্রিট, এটা আবার হার্ডেনিং হয়ে যাচ্ছে। দেন এভাবে কিন্তু যে ফর্মওয়ার্ক যেটা থাকে কলামের চারপাশ দিয়ে, সো দ্যাট ক্যান বি রিমুভ কুইকলি। অর ফর এক্সাম্পল তুমি একটা বিল্ডিং কনস্ট্রাকশন করছো, রুফ কাস্টিং করছো, বিম কাস্টিং করছো, কলাম কাস্টিং করছো, সেখানে তুমি চাচ্ছ যে ফর্মওয়ার্কটা তুমি আগে রিমুভ করতে চাও, তো সেখানে তোমাকে র্যাপিড হার্ডেনিং পোর্টল্যান্ড সিমেন্ট ইউজ করতে হবে। এছাড়াও তোমার হাইওয়ে স্ল্যাব, হাইওয়েতে যেটা কি হয়, হাইওয়েতে আমরা তো ব্ল্যাক টপ সারফেস বলছি ফ্লেক্সিবল পেভমেন্ট। এছাড়া তোমার নাউডেজ ন্যাশনাল হাইওয়ে তোমরা দেখো যে বাজার পার্টে রিজিড পেভমেন্ট ইউজ করা হয়, বা এয়ারপোর্টে তোমার রিজিড পেভমেন্ট ইউজ করা হয়। সো রিজিড পেভমেন্ট বা একটা নর্মাল হাইওয়েতে হুইচ ইজ মেড অফ রিজিড পেভমেন্ট, যদি কোনো কারণে ইট ইজ নিড টু রিপ্লেস ইট, এট দ্যাট টাইম কি হয়, হাইওয়েতে তো ট্রাফিক স্টপ করে রাখা যায় না, যে মানে ফ্লেক্সিবল পেভমেন্টের একটা অ্যাডভান্টেজ হলো যে এটা রিপ্লেস করে রিপেয়ার করে কুইকলি ট্রাফিকের উপর করে দেওয়া যায়। বাট ইফ ইট ইজ রিজিড পেভমেন্ট, দ্যাট মিনস ইট ইজ মেড অফ কংক্রিট, okay, and sometimes sometimes reinforcement is used, ট্রাফিককে বেশি বন্ধ করে রাখা যায় না, সেজন্য তখন ওখানে তোমার র্যাপিড হার্ডেনিং পোর্টল্যান্ড সিমেন্ট ইউজ করা হয় হাই স্ল্যাব তৈরি করার জন্য। Also, it is used for cold weather concreting because due to rapid strength development and protection against freezing due to high rate of heat evolution. So cold climate, তোমার rapid hardening protection কি করবে? It will produce huge amount of heat. So cold climate যদি desired তোমার যে টেম্পারেচার আমরা চাই, তা র্যাপিড হার্ডেনিং পোর্টল্যান্ড সিমেন্ট ইউজ করলে কোল্ড ক্লাইমেটে, তাহলে কিন্তু এটা নর্মাল ক্লাইমেটে যে তোমার যে রেট অফ হাইড্রেশন হওয়ার কথা, কোল্ড ক্লাইমেটে র্যাপিড হার্ডেনিং পোর্টল্যান্ড সিমেন্ট করলে তোমরা ওই টাইপ অফ হার্ডেনিং, ওই টাইপ অফ স্ট্রেংথ ডেভেলপমেন্টটা ইউ উইল গেট। So that's all today. We are left with few other slides. We'll cover in the next class. Okay, thank you. Anything from your side? Hello.
Yes, sir.
Anything from your side?
No, sir.